Okay, let's take a look at the periodic table. This is a little bit more review on Chapter 5, the periodic table. Remember that the periodic table is arranged in periods and groups. Okay, periods are rows on the periodic table, so you notice they're numbered 1, 2, 3, 4, 5, 6, 7. And also, these two series down here fit in between this part. But remember, we can compress the table if we kind of pull those out and put them down below. It just makes it a little bit easier to look at. So we have 7 periods on the table, and then we have 18 columns or 18 groups on the periodic table. And know that those columns have elements that have similar chemical properties. And the reason that is because of the electron arrangement. So we also number these top columns or groups 1A, 2A, and then we skip across here 3A, 4A, 5A, 6A, 7A, and 8A. And the reason we do that is because that number 1, 2, 3, 4, 5 indicates the number of valence electrons that those elements have. Now remember, a valence electron is one that's located in the outermost energy level of an atom, and it's those electrons that determine how an element is going to combine with other elements. Okay, so it's very important that you remember why those valence electrons are such a big deal. It's because that determines how these elements are going to combine with other elements. So if we take a look at group 1 or group 1A, this first column, those are called the alkali metals. Now, don't include hydrogen because hydrogen is a non-metal. We'll start with lithium. Okay, notice group 1, it has 1 valence electron. And if you can see these little tiny numbers here in the corner, you can on your periodic table, you'll notice that shows the number of electrons in each energy level. So the periods tell us how many energy levels each element has. So for example, lithium is in the second period, which means it has 2 energy levels. The column, group 1A, means it has 1 valence electron. So 2 energy levels, 1 electron in the most outside energy level. Sodium, for example, 3 energy levels because it's in period 3 and 1 valence electron. Potassium, 4 energy levels, 1 valence electron. Rubidium, 5 energy levels and 1 valence electron, and so on. Okay, so these are highly reactive metals. The reactivity increases as you move down the column. So sodium is more reactive than lithium, potassium is more reactive than sodium, and so on. Okay, alkali metals, group 1, and those have 1 valence electron. Then when we slide over to group 2A, we have beryllium, magnesium, calcium, and so on. Those are called the alkaline earth metals. Not quite as reactive as the alkali metals. They have 2 valence electrons. So again, beryllium has 2 energy levels because it's in period 2 and 2 valence electrons. Magnesium, 3 energy levels, 2 valence electrons. Calcium, 4 energy levels, 2 valence electrons, and so on. And again, the reactivity of those elements increases as you move down the group, okay, from top to bottom. Now, we're going to skip groups 3 through 12 right here. Those are transition metals. And we're going to just pull off on those. Most of those have 2 or 3 valence electrons. You can look at those and it'll show you the numbers for those valence electrons. The numbers can kind of vary, but to stay with our system, we're going to skip those and we're going to move right over here to group 13 or group 3A. Okay, another way to cheat it is if you notice, the last number of the group is also the A group. So this is 3A, 4A, 5A, 6A, 7A, and 8A. Okay, so the boron group or the boron family is group 3A, 3 valence electrons. Okay, 3 electrons in the outermost energy levels. Boron, aluminum, gallium, indium, and so on. And again, boron has 2 energy levels, 3 valence electrons. Aluminum, 3 energy levels, 3 valence electrons, and so on. Again, the period numbers tell you the number of energy levels, and the group number tells you the number of valence electrons. Remember that Mendeleev he left some blanks in his periodic table. One of those blanks was right here where gallium is. And remember when he predicted what that element, some of the properties of that element, and when it was discovered, those properties were correct for gallium. So that gave Mendeleev's table some credibility when it came out, when gallium was discovered. So that's kind of unique about that element. Carbon is the top of the carbon family, or group 4A. Carbon, silicon, germanium, etc. Those have 4 valence electrons. Nitrogen is group 5A. Those have 5 valence electrons. Oxygen, group 6A, 6 valence electrons. That group. Fluorine group, not the fluorine group, halogens, okay, group 7A or group 17 are the halogens, and those have 7 valence electrons. They're also highly reactive, much like the metals, the alkali metals. They're highly reactive, especially with metals. They have 7 valence electrons. Notice chlorine and fluorine are both gases. Bromine is a liquid, and iodine, astatine are both solids. Okay, and then we move over to group 8A, group 18, group 8A, and that is the noble gases. And these gases have full outermost energy levels. Okay, so helium has 2, all the others have 8 valence electrons. So that outermost energy level is full, and so those elements do not combine with other elements. They are non-reactive. Okay, used in neon lights. They glow when electric current is passed through them, and different colors based on the number of energy levels that they have. So that is a quick wrap up of the periodic table. You should be able to look at it and determine the atomic number, the element symbol, the element name, the atomic mass, which is what's listed at the bottom of each of these blocks. Now remember, the atomic mass is the weighted average of all of the isotopes. So if you round that to the nearest whole number, you'll get the most common isotope for that element. Okay, you should also be able to tell me the number of energy levels it has based on the period or the row that it's in. You should also be able to tell me the number of valence electrons it has based on the group that it's in, or the column. So group 1, 1A, 1 valence electron, 2A, 2 valence electrons, 3A, 3, and so on. So that's the information that you should be able to pull out, along with, based on the color coding, whether it's a solid, liquid, or gas. You should probably also be able to tell me where the alkali metals are located, where the alkaline earth metals are located, where the halogens are, and where the noble gases are, and then just be able to understand that boron, carbon, nitrogen, and oxygen, those families are named for those elements that are at the top. So the boron family, the carbon family, the nitrogen family, the oxygen family. Should be able to locate all of those when asked. So that is, again, the most important thing, to be able to use this table. Okay, not that you memorize it or that you can repeat all of the elements in order, but that you know how to use the table. And again, to me, that's the most important thing.